Let's look at evaluation of fetal monitor tracings. What is the likely fetal outcome with a reassuring electronic fetal monitor tracing? A normally oxygenated, healthy baby. What is the fetal heart rate with a non-reassuring electronic fetal monitor tracing? A healthy or a sick baby? Most likely, it is a normally oxygenated fetus. There is a 99% false positive rate when we say that the baby's in trouble. Most of the time, the baby is okay. The electronic fetal monitor is a very good indicator of good fetal status, but it is not a very good indicator of poor fetal status. Let's look at our sequential steps in evaluating our tracing. The first thing we want to look at is baseline fetal heart rate. I think it's important to have in your mind a sequence that you always follow. First, we want to look at what the fetal heart rate normally is, which is 110 to 160. If it is faster, we call that tachycardia over 160. If it's less than that, it is bradycardia. The question is, are babies who are tachycardic in trouble? And the answer is not always. Are babies who have bradycardia in trouble? Not necessarily. So an abnormal fetal heart rate does not mean a sick baby. Baseline changes to fetal heart rate. This is what you'd expect with a normal fetal heart rate tracing, 110 to 160. This would be tachycardia, and you can see there's good variability of this tracing. And here we have bradycardia. And the important take-home is babies who have heart rates outside of the normal range are not necessarily in trouble. This is a great board question. You need to know this. What maternal medications can cause fetal bradycardia? Beta blockers are going to slow the heart rate of the mother and of the fetus. Local anesthetics, such as with a paracervical block, we just talked about this, can lower the heart rate. Fetal tachycardia can occur with beta agonists, such as ritodrine terbutaline, and atropine-like medications, parasympatholytics. Decreased variability of the heart rate can occur with betamethasone and corticosteroids. How about if the mother has systemic lupus erythematosus and she has anti-Rho, anti-La antibodies? This baby could have a complete heart block. And here is a fetal heart rate of 60s. Is this baby in trouble? No. It increases its stroke volume so it can maintain the cardiac output. It's important to remember that changes in fetal heart rate are not necessarily associated with poor fetal outcome. All right, we've talked about baseline fetal heart rate. Now we want to look at periodic changes. Periodic changes are changes in the fetal heart rate which are temporary, which are not changes in baseline, and will usually last no more than 1 to 2 minutes. We talked about accelerations in response to the NST, and those are always reassuring. And there are 3 kinds of decelerations. There is the early decelerations, the variable decelerations, and the late decelerations. Here are accelerations, and we've already looked at that. This is a rise in the fetal heart rate of 15 beats a minute or more, lasting 15 seconds or more, and they are a response to fetal movements. These are always reassuring. This is from sympathetic stimulation, and we're always happy to see accelerations. Decelerations, there are 3 of those we talked about. There are early decelerations, and this is a response to head compression of the fetus. The management is basically, don't worry. These have no impact on the outcome. You can ignore them. They are seen more commonly after the membranes have been ruptured. Variable decelerations are a response to cord compression, the umbilical cord compression. These, if they are severe, are troublesome. And a severe variable deceleration is one that lasts 60 seconds or more, drops 60 beats a minute or more. Otherwise, they are not to be worried. Late decelerations are a response to placental insufficiency. And these are always troublesome. even if they are mild late decelerations. Let's look at the characteristics of these. In your notes, you have this tracing: early decelerations, variable decelerations, and late decelerations. The mechanism of fetal heart rate early decelerations, we already said, is head compression. This is vagal stimulation, which slows the heart rate. Here we have a tracing. You can see contractions, and notice the early decelerations. The characteristic is that as the contraction begins, the deceleration begins. At the peak of the contraction, we have the lowest point in the deceleration, and then we have a gradual return. Notice that the contractions and the decelerations are simultaneous. They are superimposed on each other. Gradual drop, gradual return, a mirror image of the contraction. Variable decelerations are also mediated by the vagal nerve and are due to umbilical cord compression. Look at the difference in the appearance of variable decelerations and early decelerations. With variable decelerations, we have a sudden drop, a sudden return. I call this a box-like shape. Sudden drop, sudden return. Okay, the blue bars are the contractions, and here are the decelerations. Is there any systematic relationship between the deceleration and the contraction? No, they are variable. And notice they are sudden drops and sudden returns. Now this might be a severe. It drops 60 beats a minute. But this one here is what we call a carrot, of no clinical significance. Late decelerations are mediated through uteroplacental insufficiency, and these are always worrisome. Here we have the contraction, and here we have the deceleration. I want you to notice the baseline heart rate is about 170 to 180, so we have a tachycardia. Let me superimpose on here the decelerations. And what you see is the peak of the contraction and the lowest point of the deceleration are not synchronous. The deceleration is always late in relationship to the contraction. And that's true over here, where we have the peak of the contraction and the lowest point of the deceleration. You notice that the end of the deceleration is after the end of the contraction. So we have early, variable, late deceleration. So we've looked at baseline heart rate, periodic changes, and now we look at variability changes. This is a normal variability. These are the rapid rises and falls of the heart rate, which is a reflection of the interplay between the parasympathetic and sympathetic nervous system. This is healthy. Let me show you a troublesome fetal heart rate, and the variability is basically gone. It looks like you've got a ruler and you're drawing a straight line. This is not reassuring. Look at this tracing here. This is flat as a pancake. I don't like it. Look at this tracing here. Flat as a pancake. Let me draw a line across here, and you can see it is so flat. Decreased variability, not a good sign. The mechanism, we said, is the interplay between the sympathetic and parasympathetic. The sympathetic rises, the parasympathetic lowers the heart rate. Okay, so we've looked at baseline heart rate, we've looked at periodic changes, we've looked at variability.